In this lecture, today's lecture, I would like to discuss order of reaction. We have to see what is order of reaction. We have in the last lecture, we have already seen what is molecularity of a reaction. Order of reaction. The order of reaction, suppose we have a reaction. Suppose you have a reaction of this type, AA, and this is suppose this is BB. Suppose this is the chemical reaction where the reactant A moles of reactant A collide to form B moles of B. A the reactant, capital A, and B the product. And the small a and B are their number of moles. Now, suppose we determine experimentally the rate law of this reaction. How the rate of this reaction is affected by change in the concentration of reactant A. Because we know that the rate of any chemical reaction depends upon the concentration of the reactant. Higher the concentration of reactant, higher will be the rate of reaction. So we want to see how many times the rate increases when concentration of A is double. How many times is double? Suppose the concentration of A is double, and then the rate of production of A, this is plus dB by dt, this is rate of production of A, and per mole we are rate of production per mole, that is 1 by B. This is proportional to, suppose, this is proportional to when the concentration of A is double, the rate increases 2 times. The rate is double. This means the rate of formation B is double. So we write that concentration of A square bracket. This square bracket is the molar concentration term, and power is 1, indicating that when this is double, this will be double. We can also write this in this way: the rate of reaction, that is as concentration of A. This is when this mathematical equation will apply if the rate is will increase as many times as the number of times the concentration of A is increased. If A is double, the rate is double. If A is stable, the rate is stable. If A is increased 4 times, the rate is also increased 4 times. This is the rate of the reaction. And again, the concentration of A is 1. This is the order of reaction. Here, order is 1. This is known as rate law of the reaction, and power of the concentration term in the order of reaction. We say that the order is 1 and it is the first order reaction. Now suppose when the concentration of A is increased 4 times, 2 times. When the concentration of A is increased 2 times, then the rate of formation of B, that is rate of reaction, increases 4 times. Then this mathematical equation will be of this type. This, when A is double, concentration of A is double, double power 2, 4, the rate will increase 4 times. Then the order of reaction is 2. Then the order of reaction will be 2. So what is the order of reaction? The order of reaction is the power of the concentration term appearing in the rate law of the chemical reaction. It is the power of the concentration term appearing in the rate law of the reaction. The sum of the powers of the concentration terms in the rate law, some of the powers of the concentration, the terms appearing in the rate law of equation of the chemical reaction is known as order of reaction. Order of reaction. Suppose, for example, just example for the reaction, for the reaction 2NO plus 2H2, this is N2 plus 2H2O. It has been found experimentally. It has been found experimentally that when concentration of that the rate of reaction increases times upon doubling the concentration of NO, concentration or preset, or concentration or preset of NO gas when keeping the concentration of hydrogen constant. Keeping the concentration of hydrogen constant. So this observation can be put in this mathematical form, can be put in the following mathematical form. That rate of formation of nitrogen, dN2, this is rate of reaction, dN2 by dt. This is proportional to concentration of NO power 2, where concentration of hydrogen is constant. When concentration of hydrogen is constant. Again, second experiment, the rate of reaction when the concentration of hydrogen is down, it is found. When the concentration of hydrogen is down, it is found that the rate is dash doubled. So this can be put in the following mathematical form, that dN2 by dt. This is proportional to concentration of hydrogen when concentration of NO is constant, is kept constant. Is kept constant. And again, it has been observed that when concentrations of both NO and hydrogen are double. Rate increases 4 times. Rate increases 8 times. This, this can be put in the following mathematical form, that is plus dN2 by dt, that is the rate of formation of nitrogen. This is the rate of reaction. That is that concentration of NO power 2 into concentration. This, according to this equation, if the concentration of NO is doubled, keeping this constant, then the rate of formation of nitrogen will increase 4 times. Because double 4. And if the concentration of hydrogen is doubled, keeping the concentration of NO constant, the rate will increase just 2 times. Rate will be doubled. And when the concentrations of both NO and hydrogen are doubled simultaneously, then the rate will increase due to this 4 times, and due to this 2 times, the 4 into 2, 8 times. The rate will increase 8 times. This is the rate law of the reaction as observed experimentally. This is the rate law of reaction as, as observed experimentally. As observed experimentally. Now, here the order of reaction will be what? The power of NO, which is 2, and plus power of hydrogen, which is 1, 2 plus 1, 3. So the order of this reaction will be ordered with respect to NO is 2, because concentration of NO power is 2. Ordered with respect to hydrogen is 1, and overall order is 2 plus 1, that is 3. The overall order is 2 plus 1, that is 3. It is a third order reaction. These two are called individual orders. Individual orders. Individual orders. And this is the overall order of reaction. So here the reaction is third order. Third order reaction. Thus, we see that the order of reaction is actually an experimental property. It can be known only when you know the rate law of the reaction. And the rate law of the reaction is determined experimentally. You can't determine the rate law just seeing the chemical equation. Okay, because if the reaction is elementary, then your gas will be okay. But if the reaction is complicated, your gas will be. So we have to carry out experiment. Okay. Now next point, the reactions have been classified. Just as the reaction is classified on the basis of molecularity as unimolecular reaction, that is molecularity is equal to 1, and bimolecular reaction, that is molecularity is equal to 2, and third molecular reaction, that is molecularity is equal to 3. In the same way, the reactions are also classified on the basis of order of reaction. If order is 1, the reaction is said to be first order. If order is 2, the reaction is said to be second order. If order is 3, the reaction is said to be third order. If reaction is ordered, if the order is 0, the reaction is called 0th order. Okay, so reactions are classified on basis of molecularity and order of reaction. Now, next point is the difference between order, order, and molecularity. Molecularity. Well, molecularity here it is molec- first write order, and here it is molecularity. DT. Order, order is an experimental property. Experimental. Whereas molecularity is a theoretical property, theoretical property. Order of reaction is concerned with the rate law of the reaction. From rate law, we can find out the order. And, and rate law is also known as kinetics. So concerns with kinetics. That is that is rate law, rate law of reaction, rate law of reaction. This order of reaction, sorry, this is also strict. First point. Second point, this molecularity concerned with mechanism. If you know the mechanism, then only you can predict what is the molecularity. Because in the mechanism, the molecularity of the slowest state will be the molecularity of the overall reaction. So concerns with mechanism. Third, it may be it may be any number, any number, integral or fractional. Even zero also, even zero order maybe one, two, three, zero, half, 1/3, 1/4. It may be any number, integral or fractional, even zero also. Always, always a whole number, whole number. Never zero, never zero or fractional. Fourth, fourth, order may change with changing experimental experimental conditions. Experimental conditions. For example, just this, let us see an example of a reaction whose molecularity changes with experimental conditions. Consider this reaction CH2, CH2, CH2 is it's a cyclopropane gas. This cyclopropane gas, upon heating, converts into CH3, CH, double bond CH2. This is cyclopropane and propane. This is also gas. This reaction is called isomerization reaction because these two are isomers, isomerization. Isomerization reaction. Now, this reaction at high pressure, high pressure of cyclopropane gas, this is case one. At high pressure of cyclopropane gas, this reaction obeys the rate law, rate proportional to concentration of cyclopropane. That is, power of cyclopropane concentration is 1. So order is 1. And in another case, that is case 2, at at of cyclopropane, cyclopropane gas, the rate law of this reaction has been found to be proportional to concentration of cyclopropane over power 2. That is order is here, order is 2. So the same reaction at high pressure is first order and at low pressure is second order. So we see that the order may change, we change in the experimental condition. But as far as this is concerned, molecularity is concerned, it is invariant. Invariant. That is, does not vary with condition. So this is the difference between your order and molecularity of reaction. 7.